Hello and good morning, CSI 257 students, for the first 8-week term of the fall 2014 semester at Anne Arundel Community College. Today's video tutorial is going to be on the PacketTracer Skills Integration Challenge, PacketTracer Activity 9.3.1.4, which is the last big skills integration challenge for the CSI 257 course. So let's go ahead and jump in. We have our addressing table and our scenario, and I'm going to scroll down here so you can see, as a network technician familiar with IPv4 addressing, routing, and network security, you're now ready to apply your knowledge and skills to a network infrastructure. And so here are our tasks. We're going to be doing some variable length subnet masking with IPv4. We're going to implement multi-area OSPF, and we're going to secure access to the VTY lines using access control lists. All right, so first things first, so the R3 LAN needs addressing. So complete the variable length subnet mask design using the next available subnets in the remaining 172.31.30.0/23 address space. And so this is going to be for the R3 LAN, so we'll jump over here and we're going to say this is going to be for the R3 LAN. And we know that we're looking at 172 dot, and of course, just covered it up, 3130. 172.31 dot, whoops, I'm going to escape out of that, and it's now gone nuts. All right, let me back this up here, Control Z. All right, 172.31.30, whoa, .0/23. And so we know from our subnetting that this could be 2/24s. It could be 172.31.30.0/24 and 172.31.31.0/24, right? If we were to look at it as /24s. So it says assign the first subnet for 120 hosts to the R3 LAN. So we want to make sure that we right-size this. And as you can see here, both of these LANs, the R3 LAN 1 and the R3 LAN 2, are asking for 120 hosts. So we know that a /24 is going to give us 254 hosts. So a /25 is going to give us 126. And remember, the way that we do that is to take a look at in this instance, it would be the last octet, where we would be saying we've got .0.0.34567 right? And if we were to go into and borrow into these host bits and borrow for the network to make it a /25, we have 7 bits left over. And remember, the host formula is 2 to the n minus 2 is equal to the number of usable host IPs, and so 2 to the 7 minus 2 is 126. Because 2 to the 7 is 128 minus 2 is 126. So we know that that would be a valid subnet. So if we were to go ahead and take this 172.31.30.0, we could say that for the R3 LAN 1, we would be looking at 172.31.30.0/25. And then that would mean that the next subnet is going to be 172.31.30.128/25. And so we're going to get 2 /25s out of a single /24, just like we got 2 /24s out of a single /23. So these right now look like they're going to be our subnets. And so let's go ahead and take a look at that. So it says assign the second subnet for 120 hosts to the R3-2 LAN. Document your addressing scheme by completing the addressing table. So assign the last IP address in the subnet to the appropriate R3 interface. And so we're going to be looking at router 3 first here. And this is interesting because throughout the term, we've been using, in most instances, the first usable IP address. All right, so let's go ahead and take a look here. So If I mouse over, it should show us the interface. Let's see if it shows us the interface. To the R3 LAN. No, it's not letting us mouse over. So we'll go ahead and take a look here. We'll go from user exec mode into privilege exec mode, and I'm going to do a show IP interfaces brief. And let's see which interfaces we have so far. So we see that the serial 001 interface is actually in area 0, and the 2 gigabit Ethernet interfaces are in area 30. And so it's gigabit Ethernet 00 and 01. And so I'm going to go ahead and we're going to take a wild stab here and say that this is the interface that's going to be gig 00. And so let's do that. Let's go ahead and configure that interface. So I'll say config T, so we're going to global config mode, and then to assign the last IP address to the appropriate R3 interface, I'm going to go ahead and say interface gigabit Ethernet 00, and let's go do go ahead and do a no shut, and sure enough, that is the gig 00 interface. You can see the light has transitioned from red to green, and the R3 LAN 1 is orange. Spanning tree is doing its calculations and configurations, and it's going to go ahead and come up here in a couple seconds. And so let's get this IP address on there. So again, it says assign the last IP address in the subnet to the appropriate R3 interface. And so we had initially configured over here for this is going to be the R3 LAN 1, and this is going to be the R3 LAN 2. So the last usable IP here would not be 127. You can see that it would stop at 127. 127 again is going to be the broadcast address. So the last IP is actually going to be .126. The last IP in this subnet would be .254. And so let's go ahead and make that configuration and see if it sticks here. So we're back over here, and I'm going to say IP address, and it's going to be 172.31.30.126. And our subnet is 255, subnet mask is going to be 255.255.255. And for a /25, we're borrowing one host bit, so that first host bit value is 128. All right, so that would be the IP address that we would put on that interface. And sure enough, that is correct. We did get the points for that. All right, so it says assign the first IP address in the subnet to the PC. And so the first IP address in the subnet would be .1. And again, typically with the PCs, we had been assigning IP addresses of .10, but we're going to go ahead here. And they've mixed it up a little, 172.31.30.1. And again, it's going to put the default Class B subnet mask in there because we are using a Class B address. However, we have subnetted that Class B address down, or applied a Class C subnet mask to that Class B address. And so our default gateway, which we just configured, and again, that default gateway is the gateway of last resort. It's the address that the PC is going to send traffic to that it does not have a route for or a network statement for. All right, so 172.31.30.126, and there is no DNS configuration, and so we'll close that down. Or actually, we'll bring it back up here, and real quickly, just to confirm, can I ping my default gateway? 172.31.30.126, and that works. All right, and then from the router, can I ping 172.31.30.1? And sure enough, we can. So the router can ping the PC, and the PC can ping the router. All right, so configure addressing for R3, PCE, and PCF. So it said assign the second subnet for 120 hosts to the R3 LAN 2. However, it doesn't tell us here to do R3 LAN 2, but we are going to do that, right? So it just says document your addressing scheme, apply the last IP address. So it's implying here that we're going to be configuring this interface as well. And so let's jump back onto R3. And we'll slide this over here and then drop it down so we can hopefully see R3. There we go. All right, so we're going to switch interfaces now, and we're pretty certain if I do a do show IP interfaces brief, pretty sure that it's going to be gig 01 there. So we're going to say interface gigabit Ethernet 01. I'm going to say no shut. And sure enough, you saw the lights transition from red to green and orange. And it's orange on the switch side because spanning tree is doing its configuration and calculation. And so let's go ahead and add our IP address here. So again, this is going to be the last IP address in the second subnet that we configured, 3130, and it was the .128/25. And so the last IP here, the last IP address is going to be .254. All right, and again, it's the same subnet mask of 255.255.128. And so we'll enter that in there, and that is the IP address for that interface. We're also going to want to go to the PC, PCF, and PCF is going to have the, PCF back up here with the desktop, is going to have the first usable IP, which is going to be 172.30.129. Because again, .128 is the subnet ID or the network ID. We're going to go ahead and use the same Class C subnet mask that we've been using, and our default gateway is simply the address we assign to the router interface. So 172.31.30.254, and we will go ahead and close that down. And so let's go ahead and test. Can I ping my default gateway? 172.31.30.254. And sure enough, that works. If I come back to router 3, can I ping my PC? 172.31.30.129, and it works. All right, fantastic. So we've got the addressing scheme set up here for the R1 LAN. We've applied the addresses to the correct interfaces, and we've also gone ahead and set the PCs up. All right, so we've configured the addressing for router 3, PCE, and PCF, and we noticed that router 3 already had that interface configured, the serial 001 interface on router, on router 3 was already configured for us as a /30. So let's go ahead and move on. So implement multi-area OSPF using 1 as the process ID. So assign the serial links to OSPF area 0. So now we've got 3 routers, right, and a total of 4 links. So router 1 has 2 links. Router 3 and router 2 each have a single link, and those links are all in area 0, our backbone or transit area. So let's go ahead and get OSPF set up here. So on router 3, we'll start here. So we'll say router OSPF 1, and I think it's going to ask for the router IDs as well. It does. So we're going to go ahead and say router ID 3.3.3.3. So we'll add our router ID in for router 3, and then we want to assign the serial links to OSPF area 0. So I'm going to go ahead and put that here in the global config, and I'm going to look down to see if they want it at the interface level or not. Yeah, so they may want, so we've got authentication that's going to be configured. So I'm going to go ahead and drop into the, let's see, we'll go interface serial 001, and I'm going to say IP OSPF, OSPF. If you do the question mark, you can see here where it's going to ask you for the different information, and it does not look like OSPF, and we'll put the network, and we're going to drop, no, we don't want the network there. All right, it looks like it may want it back into router OSPF 1, and so we'll do network, and the serial interface is going to be 172.31.31.254 with a subnet mask of /30, but we're using the wildcard mask here, right? So the wildcard mask would be 0.0.0.3, and then this is going to be an area 0. And let's see if we have got this correct here. All right, so that's correct. Okay, so we've got that properly configured, and we've put that into area 0. Let's step up to router 1, and we're going to go ahead and do the same thing to router 1. And you can see the 2 serial interfaces here are 001 and 010. So we'll go from user exec mode into privilege exec mode. And then from privilege exec, we're going to do a show IP interfaces brief just to get a quick lay of the land here. As you can see, there are multiple serial interfaces. However, it looks like the two that we're going to be interested in are 000 and 001. Serial 010 is this interface here that takes you out to the internet. So we're not going to touch that one right now. So let's go ahead and go into global config mode, and then we're going to go into router configuration mode. And the first thing we'll do is we'll set our router ID to 1.1.1.1, and then we're going to add in the two network statements. So the first network statement is going to be 172.31.31.249, and this is going to be, again, it's a /30, so it's 0.0.0.3, and he'll be in area 0. And let's go ahead and make sure, yep, we got the points for that. And then the next one would be, whoops, 253. And let me double check that. So hold on one second. So we put the interface for router 1, that's the actual IP. So if that's a /30, it would be a 248. So let me back up here. And we're going to take this guy away. Hopefully it's going to let us take that away. And deduct the points. Let me do show run. Make sure. Okay, it did. So the 249 that you see up here is actually the IP address, and I want to make sure that we use the network ID. So if it's a /30, and we'll come over here, we'll jump onto a new page. So if it said 172.31.31.249, we know that the network IDs are always even, the broadcast addresses are always odd. So if it's a /30, and you can see we've got another /30 right here that's going to end up at 253 on one side, 254 on the other. So for the second one, if we work our way back, we would say that it would be 172.31.31 dot, and it's going to be 252. The usables will be 253 and 254 with the broadcast of 255, right? So we'll say bcast. And this is going to be the network ID. And so when we see this IP 249, we know that the network ID is going to be 248. The first usable is 249. And then 250, and our broadcast is going to be .251. So that's the broadcast. And this is the subnet of the network ID. And here are my two usable IPs. Usable IPs, and I think it's actually usable IPs. There we go, sorry. So 249 and 250, and then the same thing here, 253 and 254. So I just wanted to adjust my save, and I just caught that as I was typing it out. So we're going to say network 172.31.31.252, and then it's going to be a /30, and that'll be in area 0. And so we're going to add that in there, and then we're also, and as you can see, the adjacency came up, whereas before when I typoed it, it did not. And so then the next one would be 248, right? And so we'll add that in, and we've got that set up. Is that correct? 248, 3131. Let me double check here, and that is correct, and that is also in area 0. Now the adjacency has not come up yet on the second, the interface, or I should say the network statement we just added in. We've got to do the other side in order to bring that up. And so we've got the router ID and we've got the network statements in there for the network interfaces. Now let's go ahead and jump onto router 2, which I think is the only router we have not configured yet. Let's drop this down just a little bit. There we go. All right, so we're on router 2. We're going to go from user exec to privilege exec, and we're going to do a show IP interfaces brief. And let's take a look here. So you can see that the LAN interfaces for R1, LAN 1, and LAN 2 are already set up. And there's our single serial interface, 172.3130.250, and it's going to be in this network right here. And so let's go ahead and set this guy up. So router 2, we're going to go into global config mode and then into router config mode. And the first thing we want to set is our router ID, which is going to be 2.2.2.2. And then the next setting we're going to do is for our network interface. So we're going to say network 172.31.31, and again the network is .248. It's a /30, so 0.0.0.3, and this is in area 0. And once we do this, we should now see that we have, there it is right there, neighbor adjacency is formed with router 1. So if I do a do show IPOSPF neighbors, the neighbor is identified by the router ID, which is 1.1.1.1, telling us that that is in fact router 1. Same on router 3. Do show IPOSPF neighbors, and my neighbor is router 1. And so then on router 1, he should have two neighbor relationships, do show IPOSPF neighbors, and he does. He is adjacent with router 3 and router 2. It shows that he has that the state is full, right? And there's no DR or BDR election here, right? Because we are on serial point-to-point interfaces. So if I do a do show IP protocols, you can see we get some information here for IPOSPF, or I'm sorry, for IPOSPF, for OSPF area 1, right? It's normal area, it's not a stub, it's not an NSSA or a not so stubby area. It shows the different routing sources that I'm learning from, right? And it also shows us which networks we're routing for, right? Okay, so if I do a do show IP OSPF database, we'll see our router link states, right? Our LSA type 1s for area 0, right? And so here they are. And you can see that the advertising router is in fact the router ID that we set. So it just basically says that this router LSA is coming from the advertising router, in this case router 3, router 1, and router 2. All right, so now that we've got that set up, let's go ahead and take a look here. So configure the router IDs have been done, area 0 has been done. So summarize the LANs in each area and advertise them using one network statement. So we're going to go ahead now and do a summary. We'll start with router 1. As you can see here, a summary on router 1. If I do a do show run, and we want to see the OSPF, right, we have no entries in here for the networks that router 1 would be advertising. If we take a look, you can see that there's /23s, right? So there are two /23s here, 172.31.25.254 and 172.31.27.254. So we have two /23s, and we want to come up with one area range command that's going to allow us to make to accomplish the summarization here. So if I come over to my sheet, and let's go ahead and we'll, again, it's kind of a review here for the summarization that we've already done, and let's take a look. So we've got 172.31.25.254, and then we have 172.31.27.254. So where is the interesting octet? So these 8 bits match, these 8 bits match. However, there is the interesting octet. Here is where they do not match. So we have 16 bits that match. Now we're going to go ahead and take this and go from decimal into binary. So if I had my 3, 4, 5, 6, 7, 8, we'll just put them as all zeros right now. So we know that the value here is 128, 64, 32, 16, 8, 4, 2, and 1. And so from looking at this, you can tell that the 25 and 27, neither of these three, or these three bits, these bit value locations will not be on because it's greater than the numbers we're dealing with, 25 and 27. So 25 would be, if I were to do 25 in binary, it's going to be 0, 0, 0. 16 would be on, the 8 would be on, that's 24, and then, oops, 0, 0, 1, and that's 25. So 27 would be 0, 0, 0, 16, 24, that would be off because it would make it 28, but then 25, 26, 27. And so now let's take a look here and see where do the bit positions no longer match. So we're good here, we're good here, and here, and here, and here, and here. It's right here where they no longer match. Now, it's important to remember that we have two bit values that do match, that we need to make sure that this is the value for our summarization. So we've got 1, 2, 3, 4, 5, 6 bit positions that match in addition to the 16 we already have. So right now we know it's going to be a /22, and the address would be 172.31. And this is where these values come into play, right? So the 16 and the 8 are on, so that's going to be .24, and then everything else gets blanked out, right? So .24.0/22. And remember that the 22 signifies the subnet mask, and so in dotted decimal format, that's going to be 255.255, keeping in mind that that's 16, and so then the next 6 bit locations are going to be on, so it would be 1, 2, 3, 4, 5, 6, right? So it'll stop right there. So 128 and 64, oops, is 192, 224, 240, 248, and then 252. So 252.0. So that would be our summarization that's going to represent, that's going to represent all of the lands, and we're going to say this is R1 lands. Okay, so that's going to represent all of our R1 lands. Okay, so let's go ahead and put in that statement. So we are in router configuration mode. We are on router 1. So if you do a question mark, you can see that there are a number of different choices, and we're going to go ahead and say network. Oops, I'm sorry, we're not going to want network range. We're going to want, I'm actually drawing a blank right now. We're going to want, is it area 0? Yeah, area 0 range. I apologize, drawing a blank there. All right, so the IP address that we're going to match is going to be 172.31.24.0. And if I do the question mark, you can see it wants the wildcard or the IP address of the mask. So we're going to go ahead and say 255.255.252.0. So not the mask, the IP mask. So let's make sure this is correct. And then we're going to drop that in. And that's actually going to be area 10. And so I'm going to hit enter, and let's see if we've got that right. So we did get that correct. All right, so again, quick key to remember here is when you're doing summarization in OSPF, right, we did it here in this instance from the router config area for area 10, and this range of addresses is going to be what's summarized. All right, and so now we need to do that as well for area 20 and area 30. So we'll just do them in order here. Let's go ahead and drop over to router 2, and you can see router 2, router 2's lands are going to be both /24s, right, for 172.31.28.0 and 172.31.29.0. And so we know that 2 /24s typically falls within a /23. So let's turn the page here, and we're going to say this is going to be our R2 lands, right? And so we said that it's going to be 172.31.28.0/24 and 172.31.29.0/24. And hopefully after working with these for a while, we're going to guess, we're going to do it, we're going to work it out anyway, but let's go ahead and I'm going to take a stab here and say that that's going to be, we're going to end up with 172.31.28.0/23. And again, same process. Here's our interesting octet, right? So these 16 bits match. And so now let's take a look at 28. 1, 2, 3, 4, 5, 6, 7, 8. And again, the bit position values are 128, 64, 32, 16, 8, 4, 2, and 1. And so we know that we're going to be, draw a line in here, that for 28 and 29, we're not going to use these 3 bits. We're going to start over here. So for 28, it would be 0, 0, 0, oops, 0, and then 24, 28, not that, because that would make it 30, and then, I'm sorry, I did that backwards. I was doing 29 first. So 24, 28, and then this guy is the 0, and then 29 is 0, 0, 0, and this is 1, 1, 1, 0, 1. And so if we take a look, these match all the way right up to here, that 24th position. So right now we know we've got the /23, so we're tracking with what we had hypothesized over here, what we had guessed. Maybe this is going to be a /23. And so now let's add these up. So 172.31. And we have to get these bit values here for these 3 bits. And so it's 16, and 8 is 24, and 4 is 28.0/23. And so it is exactly what we thought it would be. And the dotted decimal notation for our subnet mask, since it's a /23, is going to be 255, 255, 254.0, right? Keeping in mind that this 254 comes from the fact that it's a /23, which means 7 of these bit positions have been borrowed for networks. So 128 and 64 is 192, and then 32 is 224, 240, 248, 252, 254. And that's where we came up with the 254. All right, so let's go ahead and let's drop in the area range statement on router 2. So we'll go from user exec to privilege exec into global config, and then into router configuration mode. And so we're going to say area 20, and again, it's going to be the range. And so we're going to say 172.31.28.0, and it's asking for the subnet mask, not the wildcard mask. And that is it. Oops, I apologize. Area, did I get that? Make sure we got that right. And range, and 172.31.28.0, and 255, 255, 254.0. There we go. Okay. I think I had a typo in the previous command there. All right. So we've got that in, and we've actually been given the points for that. And so now we'll move on to router 3. And remember, we've already done router 3, the calculations for the subnets. And so we know that those 2 /25s are a single /24, so we're going to shortcut this. So router 3 will go from user exec into privilege exec, and then into global config, and then into router configuration mode, where we're going to say area 30. And did I say area 20? I did. Okay, just checking. All right, so area 30, and we're going to say range, and then the IP address. And so if we take a look up here real quick, we'll drop back here a couple pages. We'll go back 1 page, and then 2 pages. We're on the R3 LANs here. So here's our R3 LANs, where we were talking about the fact that we're using 2 /25s here. Well, it's actually, these 2 /25s are a single /24. And so if we took a look at that, we would say it's 172.31.30.0, and it's going to be a /24. So 255, 255, 255.0. So we've added that in, and then we've got the points for that. So we've assigned the R1 LANs to OSPF, or we haven't done this yet. We've just summarized each LAN and advertised them using one network statement. So now we want to put those interfaces specifically the interfaces, into the proper areas. So it says assign the R1 LANs to OSPF area 10, 20, and 30. So let's go ahead and do a do show IP route, and let's see what we know about right now. So you can see here that all we're learning about right now from OSPF is about the directly connected serial link that we have into area 1. So if I'm on R1 and I do a do show IP do show IP route, you can see that we're not learning anything in OSPF. And if I'm on router 2 and I do a do show IP route, I'm only learning about my directly connected network that I've configured. All right, so taking a look at the next step, it says summarize the LANs in each area, advertise them using one network statement, and we've done that. But now we want to make sure that we get the R1 LANs into the proper area, the R2 LANs into the proper area, and we want to prevent routing updates from being sent out the LAN interfaces. It says do not use the default argument. So what it's talking about there is passive interface default. So let's start on router 1, and we want to make sure that the LAN interfaces do not get the routing updates, and so we're going to go ahead and say default interface, whoops, and that is not the command that we want. So we want passive interface. We don't want to use default. I was thinking about default from having read it. So passive interface, we're going to say gigabit Ethernet 00, and then we're going to say passive interface gigabit Ethernet 01. And those are the two LAN interfaces on R1. We'll come over to R2, we'll do the same thing. Passive interface gig 00, passive interface gigabit Ethernet 01. We're taking care of some low-hanging fruit here, and then back onto router 3, we're going to say passive interface gigabit 00 and passive interface gigabit 01. And so those interfaces will not be sending the OSPF updates out. So now we're going to take a step back here. So we're going to assign the R1 LANs to OSPF area 10. So I'm going to go ahead and go into interface gigabit Ethernet 00, and I'm going to say IPOSPF, and if I do a question mark, you can see we've got the cost, the priority, message interval dead. So it looks like we may have to drop these interfaces. We've got the summary. I guess we're going to put it back here. We're not going to drop it on the interface. So we'll go back to router configuration mode, and I'm going to say network, and this is where we'll add in the specific networks for those interfaces. So network 172.31.30, and the first one is .0 and 00, and then we've got /25. So /25 is going to be a .127. And quickly to explain that, so we're using the wildcard mask, and so we know that a /25 by default, the dotted decimal is 255.255.255.128. To get our wildcard mask, we would simply subtract from 255 the 128, and that gets us 127. And so let's see if this is going to be accepted here. So now we're going to put this into area 30. So we've dropped that command in there, and that is the correct statement. So then we would come back here and do the same thing, and we simply change the network to 128, and the network is still going to have the same wildcard mask. And so we've added that in there. So it's 172.31.30.128 with the wildcard mask of 0.0.0.127 into area 30. So now if I do a do show IP route, you can see we're still only learning about our directly connected route because we haven't advertised the remaining routes here. If I do a do show IP route here, you can see we're still not learning anything over here. If I do a do show IP route here, we're only learning about our directly connected. All right, so the next phase, we've done R1, R3, let's come over to R1, and we're going to say network, and I'm going to scroll up just a tad there. So we're going to do the first LAN interface is 172.31.25. And the address that we're using is a .254. And let's make sure we get this as .0. And again, the subnet mask there, it's a little tricky. It's not a /24, it's a /23. So we'd be 0.1.255, right? And it's the same principle when we look here. So we're going to subtract both of those octets from 255. So we end up with .1.255, and then we're going to say area 10, and then we are going to go ahead and drop back here and say .27.0, and that is also in area 10. And again, we've got the range statement, which is summarizing those two /23s into a single /22. All right, let's step over here to router 2, which we have not done yet. And so we're going to say network, and the first router 2 network is 172.31.28.0, and these are convenient /24s, 000.255, area 20. And then the next one is going to be .29. And again, the same statement. So there we've got our two networks added in. So we have assigned the R1 LANs to the correct interfaces, to correct areas, as well as R2 and R3. So it says implement default routing to the internet. So on R1, we're going to go ahead and configure default information originate. And if I do a question mark, that's it, right? So very simple to set up the default route. However, let's take a quick look here. If I do a do show IP route, do we have our gateway of last resort set? It is not, right? So we want to advertise the default route to R2 and R3. However, we have not set up the default gateway yet. So let's go ahead and set that up. Let me exit out and we'll go to global config. We're going to say IP route, and then the default route would be out interface from R1. It's going to be serial 010, and so we'll use the interface. Oops, serial 010, and that's okay. It is a point-to-point interface in this instance. So now if I do a do show IP route, you can see that our gateway of last resort is set, right, to network 0.0.0, and there it is, out serial 010. All right, so now when I go back into router configuration mode and I type in default information, default information originate, and before I do that, just real quickly, you can see here that do show IP route, they've got no default route, gateway of last resort is not set. Do show IP route, gateway of last resort is not set. So now I'm going to use OSPF to dynamically propagate the default route out to router 3 and router 2. So now if we run that command again, aha! So the route is still not set, and there it is, right? So we had to wait for the update. So there is our default route telling us that it's an external type 2 OSPF route, and we'll come over here to router 2. And he also has a external type 2 route, E2, which is the default route, telling me to go to the next hop interface here on router 1. So now these guys do have a way out to the internet, and they also have a path out of, or router 2 has a path to just simply get out of the area 20 as well as the area 0. So if I'm on PCC, which has already been configured, we'll come over here, let's take a look at the configuration. You can see the configuration there. My default gateway for my PC is not router 1 because he's not local to me. He's not on my local network. So for PCC, my default gateway is router 2, specifically this interface right here. However, let's see if we can ping around the network. So can I ping, and and I'm on R2. So let's try 172.31.28.254, my default gateway. So I can get there. Can I ping a PC? Let's try PC A, who is up in area 10. So I'm going to ping 172.31.31. I'm sorry, 31.24.1 is PCA. So I've got a default gateway statement on the PC, which allows me to get to the default router. However, you'll notice when I get to the router, it's timing out. Even though the router has a default route, the traffic is still not working. So something may be wrong. So we're going to keep plugging away here and see what happens. So we've just advertised the default route. So now we're going to configure MD5 authentication on the serial interfaces. And if you remember, there's three different types of authentication within OSPF, right? You've got your null authentication, which means none, and that's what we're doing right now. We have no authentication set up. You've got your what they call just simple authentication, which is plain text, right, where the password is going to be in plain text, which is not very secure. And then finally, you've got your MD5 authentication, which is going to use an MD5 algorithm that they typically refer to as the MD5 hash, right, for your signature. And so this says we're going to implement or configure authentication on the serial interfaces. And so there's a difference. The two ways to do the authentication in OSPF, you can do it globally, right, and that's going to enable it on every single interface, or you can do it on specific interfaces. And so it looks to me here that it's asking for it to be done simply at the interface level. So let's test it on R3 here. So R3, if I do a do show IP interface brief, we know that we're using serial 001. So let's go to serial 001, and at the interface level, we're going to type in IPOSPF message digest key, and again it's saying the key is just going to be 1. We're using MD5, and then it wants the password, and I believe the password here is simply going to be Cisco123. So I'm going to go ahead and do a question mark, and that's it. So I'm going to hit enter, and we'll see if we end up with a valid configuration here, because there's one more command that we need to run, and that command is going to be the IPOSPF authentication. Let me make sure I get this right. So IPOSPF and authentication, some spelling challenges this morning. Authentication message digest, right? So those are the two commands that need to be run. We need to do the IPOSPF message digest key, defining the key, and the MD5 hash password, and then we need to say IPOSPF authentication, and we're using message digest, right? Okay, and I'll hit enter, and so now we've configured authentication on the interface itself. So if I do a do show run, and we're coming down to serial 001, that's what we have for the authentication on that specific interface. So now let's come over to router 1. So router 1's interface to router 3 is that one right there, and it should be 254, 253. It should be serial 001 as well. So let's go interface serial 001, and I'm going to go ahead and say IP, and this is excellent, right? So the authentication is working, and we had to wait for the next update to be triggered, but you'll notice router 3 had the dead timer expired, and the authentication's configured on router 3, but we're not configured on router 1. And so you can see here that the adjacency between router 1 and router 3 is now down. So if I do a do show IPOSPF neighbors, do show IPOSPF neighbors, you can see that the adjacency that exists on router 1 now is solely router 2 because we haven't done any authentication there. So now let's go ahead and configure the authentication here. So IPOSPF message digest key is key 1. If I do a question mark, you can see the only choice we have here is MD5. So MD5 with a question mark again, and it's going to be our password, which is simply Cisco123. So we enter that in, and then the next command is IPOSPF authentication, and we're just simply telling it that we are using message digest. And so then we'll hit enter there, and now we're going to go ahead and wait a few seconds here because what we should see happen, and there you go, an update got sent out, and the adjacency between routers 1 and 3 has now gone from down, which the state it was in, to full, right? And it's transitioned through the other states, but it's now full. So if I do a do show IP OSPF neighbor, so router 3 and router 1 are now adjacent again, right? So if I do a do show IP protocols, right, we can see here that for on router 1, for OSPF area, or for process ID 1, we've got no filters, we've got our router ID, and everything looks good. And you can see that it's routing for these networks, right? We've got passive interfaces listed here, and our routing information sources. So we have adjacencies established with router 2 and router 3, right? So if I do a do show IP route, you can see here that we are now picking up the summary, right? And I always say these backwards. So the inter area, right? So you've got your intra area, which would just be the O, and the IA after the O is for the inter area, right? So again, this is an inner area route that we're learning, and it's inner area because remember this 172.31.30, which we're learning from router 3, and again, I'm on router 1 here, we're learning this from router 3. This is our summary that we configured for, and it's actually right over here still, for the 2/25s, we ended up with a single /24. And this is that summary, right? And so we've learned that summary route here. So what if I do a do show IP OSPF database right now? So you can see here, I have to scroll up a little bit. So there's where we start for area 0. So here are the router link states. So these are our type 1 LSAs. But then we have some summary network link states, right? And these are coming from router 3, and you've got the or the 172.31.24s from router 1, and then the 172.31.28s from router 2. And so those are your summary network link states. And then you've got for area 10, you've got your type 1 LSA, and then you've got your summary link states here, and then we even have a type 5, right, which is our default route. And so that's an external LSA, a type 5 LSA that we're going to learn. Okay, so, and these are, the summary net link states are our type 3s, because we're learning those from different areas. Okay. Or I'm sorry, yeah. Let me make sure I got that right. So let's scroll back up here. OSPF process ID 1. Correct. That is correct. Okay, good. So your summary net link states are being picked up as well. All right. So we've taken a look at router 1. We've set the authentication up between router 1 and router 3. Then let's do router 1 and router 2. So do show IP interface brief. And the router 2 link is going to be serial 000. So interface serial 000. And I'm going to go ahead and we're going to do the same command. So IP OSPF. Message digest key is going to be 1, MD5 is the type, and the password is Cisco CSI257-8xx. and then IPOSPF Authentication Message Digest. Now, between R1 and R2, we never set the R2 side up, so what we would anticipate that we're going to see here as soon as the dead timer expires is that this adjacency between router 1 and router 2 is going to go down. So we'll pop over to router 2 here and go from user exec to privilege exec into global config, and I want to do a do show IP interface brief, make sure we have the right interface here, serial 000, and there you go, the adjacency has gone down. If we go back to router 1, you should see the same thing, and we do. Alright, so let's configure that serial 00 interface to properly authenticate. And so we're going to say IPOSPF message digest key 1 MD5, and whoops, and the password is Cisco123, and then IPOSPF authentication message digest. And so now we would anticipate that the OSPF adjacency between router 1 and router 2 is going to pop back up here. And what we're going to see is the process ID come back, or I'm sorry, the process come back up for process ID 1, right? And remember with OSPF, when we say router OSPF 1, that is a locally significant value. It is not similar to the autonomous system number that's used in EIGRP. Okay, so we've set up authentication on all of the routers so far. The serial link, so let's do a show IP OSPF interface. Whoops. Do show IP OSPF interface. And you can see when we take a look at the interface types, we've got the gig00 interface as a broadcast interface. And let's get down to, and there you go, 01 is a broadcast interface. Also shows that the DR state, it shows the DR designated router ID, we're on router 2. And actually, I think it went right by, I missed it. Serial interfaces, where are we at? There we go. So here are the serial interfaces. You can see the network type is point-to-point, which is why we do not have a BDR election that takes place. You've got your hello and dead timer values that show here, right? And most importantly, the message digest authentication is enabled. So it's the show IP OSPF interface command that we want to take a look at that's going to show us, hey, are we using message digest authentication? And it also shows you the youngest key is key ID 1. And again, that was show IP OSPF interface. All right, so the authentication is set up. Now we're going to limit VTY access on R1. So let's get R1 up here. And we want to configure an ACL, so it's going to be a standard ACL that only allows PCA to telnet into R1. So we're going to say access list, and if I do a question mark, it's a standard access list 1, right? And we're going to permit, and we want to permit PCA, and there's the IP, it's 172.31.24.1, and that's, we could do the wildcard bits on there, and we're going to say just that IP address, and so that's equivalent to saying only that IP address. So we'll do 172.31.24.1 0.0.0.0 and hit enter. All right, and we just got the 5 points for that, and then only PCA is allowed to telnet into R1. So we're going to go line VTY 015. So we're going to grab all the VTY lines, and then we're going to say IP, and if I do a question mark, you can see access class, and the word, or the access list name, it's just one, oh, I'm sorry. We're going to do access class, yeah, so I don't want IP. That would be for the extended if I had it named. So we'll say access class, I apologize there, so the access list number is 1, and we're going to say in, right? So it's going to check that access list to see is anybody else trying to come in who is not the 172.31.24.1 PC. And so let's go ahead and do a do show run. Not the most efficient way to get there, but we're going to come take a look down here. So VTY 0 through 4 and 5 through 15. The password is Cisco, and the access class has been set. Now we don't have to put in here transport input all or none or SSH or Telnet. By default, it's going to take both SSH and Telnet, so we can leave that, I believe. We'll see here because we're 6 points short, so we're going to take a look at our results here in just 1 second. So can I Telnet in from PCB? Let's give it a try here. So if I say Telnet 172.31.24.1, connection refused by remote host. All right, what about from PCA? So we'll say Telnet 172.31.24.1. Aha, connection refused by remote host. So PCA still cannot get in there. The connection's being refused. So let's check our results right now, because it looks like in this activity, which is quite substantial, we may have gone past something. All right, so area authentication, area 0. It looks like we've missed that on all 3 of the routers. All right, so it might want it globally set. So let's go ahead and close this down. And we'll pop into router 1. And we'll say router OSPF 1. And we're going to go ahead and say area 0 authentication to enable the authentication using message digest and see if that's what it's looking for. And that is what it's looking for. And then on to router 2, router OSPF 1. And so the fact that we're coming in here to the router configuration is telling me that when it asked us to set it up on the interfaces, that it wanted it done in the global router config area. So we're going to say area 0 authentication message digest. And then finally on router 3, we're going to do the same thing and go from user exec into privilege exec, global config into router config mode for OSPF 1. And we're going to say area 0 authentication message digest. And you remember from the reading where it said when you're setting it up globally that this is the command that you would enter in global config. Then you would go to the interface and you would only need to enter in the message digest key MD5 password. So if we take a look at our serial interfaces, you'll see that we have the configuration, these 2 commands to enable it only on this interface. However, it looks like the activity is looking for it to be done in the global mode. So what I should be able to do here on router 1 is if I go into interface serial 000, I should be able to say no, and it's going to be the authentication message digest command because we've set that globally. So I'm going to remove, let's see if what happens here. And it did not take any points away, right? So it didn't want it done just under the interface. It wanted it done globally. So serial 001, I'm sorry, I was on router 3 here. So let me jump over to router 1, and we're going to say interface serial 000, whoops, 000, and we're going to say no. We'll remove that command. We're just cleaning the config up here because that's an extraneous command. And again, I'm going to recap what we're doing here with respect to authentication. And then the other one is int serial 001, and we're going to say no, IPOSPF message digest authentication. All right, so we removed that from 3.1, and now on to 2. We're going to say interface serial 000, and we're going to pull that command off of that interface as well. So if I do a do show run, and we go to serial 000, you'll notice that now it just has the message digest key there. And again, there's two ways to do the authentication. You can do it globally, which is what this activity is asking for. And to do it globally, you would put the Area 0 Authentication Message Digest command in the global router config section that we're working with. To set it only on the interfaces, you would do it the way that I had initially done it, which is to put the two commands, IPOSPF Message Digest key and then the IPOSPF Authentication Message Digest on the interface. And so it looks like the reading of the instructions here, configure MD5 authentication on the serial interfaces. This activity was actually wanting it to be done globally, right? Not just at the interface level. And so we've rectified that. And so we've got everything set up. I'm not sure why it is not allowing us. Let's try one more time. So it says the connection is refused when we're trying to telnet to router 1. Let's take a look at the router 1 config one more time. Do show run. And it might be that the activity just isn't allowing us to make that connection. The password's there. The login is correct. Access class 1 in. Show or do show run. Let's go look at the access list one more time to make sure it's for PCA. And there's my access list one. Permit host 172.31.24.1, and that is PCA. So he should be able to telnet in there. Let me make a config change here. Let's see if this is the problem. So line VTY 015, and I'm going to say transport input telnet. And let's see if that actually makes the difference here. And it does not. So it might be that we are unable to actually telnet. For whatever reason, the PacketTracer activity is not allowing us to telnet from PCA to router 2. Let me see if I can ping router 2. Or I'm sorry, telnet from PCA to router 1. I should definitely be able to ping router 1. It's going to be 172.31.24. What was the router 1 interface? 25. Whoops. So PCA is on the R1 LAN 1. 172.31.24.1. 25.254. 254. All right, so I can ping the interface. However, oh, you know what? I've got the wrong. My apologies. I've been telnetting to the PCA address, thinking that using the .1 as a default gateway. My apologies. So our default gateway is actually 25.254, and there you go. So we can get there. So let's go back to router B, and let's make sure that I cannot ping. I apologize. So used to using the .1 as the default gateway, 25.254, and that's what we would expect to see. Yeah, so my apologies there. I was using the wrong IP address for my default gateway, which is router 1. So as we've just seen, PCB cannot connect. However, PCA, which we set the access list up for, the password was Cisco, and there you go. We are now on router 1. All right, so this was a pretty lengthy activity. This was an absolutely fantastic activity. It would have been nice to see maybe PacketTracer 9315, which dealt only with IPv6. However, this is the PacketTracer activity, Skills Integration Challenge, 9.3.1.4. I hope this cleared up any confusion you might have had. And again, fantastic activity to really apply everything that you've been learning throughout this first 8-week term. All right, thanks for watching and have a great day.